Alright, so to compare irrational numbers that are square roots, we can simply examine the number that we are taking the square root of. For example, we know that the square root of 15 has to be less than the square root of 17 because 15 is less than 17. However, when we compare irrational numbers such as square root of 10 and pi, it is simplest to compare rational approximations of each written as a decimal. We know that, which you might not know this yet, that the square root of 10 is approximately 3.16 and that pi is approximately 3.14. Therefore, we can say that the square root of 10 is more than pi. Notice that it was useful to approximate the irrational numbers to 2 decimal places in this case, even though it wasn't entirely necessary. The same is true for comparing irrational and rational numbers. By finding a rational approximation of the irrational numbers, we can compare values such as pi and 22/7. For these numbers, we may have to go to 3 decimal places for our approximation, and the use of a calculator would definitely make sense in this case. Rounded to 3 decimal places, we find that pi is 3.142, and that 22 divided by 7 is approximately 3.143, which means that pi is less than 22/7. So once we know how to compare 2 numbers, we can then order a set of numbers through a comparison of 2 numbers at a time. For example, we could list from least to greatest the square root of 10, pi, 3.14, and 22/7. We know the following: that the square root of 10 is approximately 3.162, that pi is approximately 3.142, and that 22/7 is approximately 3.143. We see that the square root of 10 is greater than all the other numbers given. We also note that if we were to have 3.14, it's the smallest because it's equal to 3.140 when we put it in 3 decimal places. Therefore, we can list them in order. So 3.14 is the smallest, then pi, then 22/7, then the square root of 10. Notice that the closer the numbers are to each other, the more decimal places of accuracy we need in our rational approximation. So, again, rational approximations of irrational numbers will be our friend. On a number line, we generally list rational number markers. On the simplest number lines, we count by integers. On a standard English ruler, we count by fractions, usually 1/16 inch or 1/8 of an inch. On a standard metric ruler, we count by millimeters, which are each 0.1 centimeters. No matter how the number line is set up, we will still need the rational approximations of the irrational numbers. So let's look at an example. Let's try to place the following irrational numbers on the number line: square root of 37, square root of 42, and square root of 24. First, we will make a quick 1 decimal place approximation of each. Square root of 37 is about 6.1 since 37 is just over 36. So here's what we're keeping in mind. So I'm going to rewrite it down here so it's a little bit easier to see. On your paper, feel free to write it however you need to. Like you can do it on the number line up above, or you can rewrite a number line like I am. So I have 4, or 4.0. Remember, that's the square root of 16. Then I have 5, which is the square root of 25. Then I have 6, which is the square root of 36. Then I have 7, which is the square root of 49. And I have 8, which is the square root of 65. If we place our perfect squares first, it's a little bit easier to see where the approximations will go. So the square root of 37 is obviously going to be b, because that's the closest to square root 36. Then we look at square root of 42. Where would that fall? Well, I know it's going to be between 6 and 7. So where do you think that's going to be? Is it going to be closer to 6 or is it going to be closer to 7? Well, if you think about it, halfway between 36 and 49, if I'm going to do a halfway point, to get from 36, so this would be 6.5, right? Halfway between 36 and 49. So to get from 36 to 49, that is 13 places, right? So perfectly halfway would be the square root of, so 36 plus 6 is 42, so 42.5. So it would make sense that the square root of 42 would actually go right in front of 6.5. Let's look at 24. The square root of 24, that would fall between 4 and 5, and it should be almost 5. I'm not quite sure why they have the letter C on there. Oh, because it looks like they're talking about square root of 46 right here. So if I were to do square root of 56, sorry. If I were to do the square root of 56, that would definitely be right here because that's between 7 and 8. Note that point A must be square root of 24, and it's just under 5. Point B must be square root of 37 since it's just over 6. And point C must be the square root of 56 since it's right at the 7.5 on the number line. In the same way that you can identify which point on a number line goes with which irrational number, you can also place points on a number line to represent the irrational number. So my suggestion to you is to always, always, always make a number line from 1 to 10 and then list out your perfect squares above them to help you rationalize where it should land.